Hey guys, a very good morning. Thank you for joining with us. My name is TN Pradeep Kumar Naidu, and we are here to represent Nikit Engineers, which is into welding from the past 42 years. And the kind of knowledge that we have gained over the past 42 years, we would like to share it with you guys to solve a much complicated problems of welding and simplify the entire process. So let's see what we're going to solve today.
So the problem that we are solving today is of cast and plate welding. So you can see the image here, guys. A cast and plate is used in construction where it's a base plate of 12 to 16 thickness, on top of which there are two TMT bars bent into a C form, and in between there is a plug. So all the five places, that is two onto the TMT bars on the left and two onto the TMT bars onto the right, have to be MIG welded, after which the plug in the center should also be MIG welded. So there are five areas of welding. Now if you look at the design of it, this was the first episode of how we design the entire stuff, or we call it DAP1, where the process goes into approval. Now if I zoom into it, you can see how we have placed two fixtures for welding the casting plates. So what happens here is we have stage 1 and stage 2. Once the stage 1 gets welded and the torch axis moves to stage 2, the stage 1 component is declamped and immediately a new component is loaded. So it saves a lot of time. It saves a lot of time for the operator, so as if the welding happens in about 20 or 30 seconds, he's got the same 30 seconds to load another component. For example, if the torch axis comes to the stage 2, he'll unload the stage 1 component and load a new component in stage 1. The same thing happens in stage 2 as well. So as you can see, we've just zoomed in on most of our fixture elements here. We've used a cam based system. There are a lot of elements here. We'll get into that in a little bit. But before that, let us talk about the axis. We've got an X axis, we've got the Z axis. We have zoomed in on the Z axis with the rotary axis. Z axis has a stroke of about 300 Rotary is again plus minus 360 degrees. Then there is the Y axis on which the entire Z axis is mounted. Y axis here is about 1.2 meters in stroke. And the X axis, we have a dual X here. As you can see, the dual X covers about 1.5 meters in stroke. So apart from these, we have also mounted a wire feeder stand which is fixed. Since the stroke of X and Y is not huge, so what we have done is we fixed the wire feeder and allowed a cable or a wire feed cable of about 1.5 meters in length. We also have a spring balance attached to it, which is currently not visible in the design. You can also observe that the display stand is onto the operator's right hand side. It's a movable one, so he can set it either on his left based on his unloading and loading capability. So now let's move on to the fixtures. If I just zoom in, or I take this separately, it's a more clear version what you need. There are about 5 clamps and a cam based adapter to load the base plate, and clamping of all the TMT bars happens in this. It's a very clear view. Now let's see how the welding is done. We'll just run a small video because the entire video takes a lot of time here. We've finished both ends of the TMT bars and we're moving on to the other ends. The kind of finish that you get and the amount of bead that it has been deposited is between 8 to 10 That is a required bead width. And the base plate we have used here is about 16 thickness. The TMT bar dia is again about 16 to 20 Now if you see, what happens is the axis interpolates, comes to that particular position and starts welding the TMT bars. The biggest challenge that we faced here is of during the weld, if we do not interpolate the axis, we don't get the exact circular position or circular profile of the component that has to be welded, the part that has to be welded. So there are about 4 plus 1, 5 circular profiles. You can set it automatically. It's based on our teach functionality, and once you set it, you just have to start the program. There are about 10 programs here, so 10 variations that you can weld. In case you want to increase the number of programs, you can also do it by extending through a USB dongle or a thumb drive. So post welding, let us see the component, how the finish has, how we have arrived on the finish. So this is the finish, guys. It's basically a test component that I'm just that we are looking at. So all the 5 sides MIG welded. So that's it on the casting plate. Let's move on to the costing of the entire project. Yeah, it's the process is MIG welding, and the costing, that is inclusive costing, we've considered 4-axis motion control system with a 4-inch display, costing us $2,200, linear axis at $3,100, the torch axis, the torch adapter, fixture assembly, frame, sheet metal, safety systems. So the entire thing is through 400 watt power consumption only, because these are through stepper motors. So the project cost is about $10,568, and non-inclusive, as I said earlier, labor, company overhead, consumables, power consumptions, installation, packaging and forwarding. So that's it, guys, as of today. Thank you so much.